Good afternoon, everyone. Let's start Flume. In previous class, we discussed Flume introduction, and Flume architecture. Flume architecture, right? So we discussed Flume concepts, Flume configuration, right? So today we'll discuss different examples. In example one. So first example, we take input from file. We take input from file. So it take like we create one file. File may be any file. So some dot log file. You can take any name. Then we create source to point this file. We create source. So source connects to this file. So we create agent. Under agent we create source. Source points to file. Then we create channel. So first we create file channel. In example 1, we create file channel. We create file channel. Next, we create sink to connect this channel, and through sink we write messages in console. Console. Okay. So this is first example. We are going to execute this way. So we take input. So whatever you enter data into this file. So continuously we are entering data into this file. Then whenever you enter any entry, source captures that data and writes into file channel. And sink reads that data from channel and writes into console. Okay, we see this example. So if you type hi, then immediately you will see in console hi. If you type hello, then you will see hello here console. So we open file and we write a text. Then this streaming data is going to read by Flume. So we create a connection between file and source, and file channel, and sync to file channel and sync to console. So let's see example. First step 1. So first we need data directory to store data directory. So we are using file channel, right? We are using file channel, right? So file channel. So whenever we enter data in this file, source reads this file and stores into file channel, right? So for storing this data, we create first a data directory and check pointing directory. Check pointing directory. So why check pointing directory? So here we are getting continuous data, right? Continuous data. Continuous data into file channel. So first we store in check pointing directory. Check pointing directory to actual directory. It will create two directories in file channel. It will maintain two directories. One is check pointing and data directory. First source writes into check pointing directory. File channel reads from check pointing directory and places into data directory. Then sync reads from data directory. Once sync writes into specified destination location, the data removed from file channel. Okay. So we create two directories. One is data directory and another one is check pointing directory. So first let's create two directories. These two directories information we provide in configuration file. Okay. Let's first create check pointing directory. Let me connect to through putty. So I am creating two directories. One is data directory and another one is check pointing directory. So step 1 we create two directories. Step 2. In step 2 we create configuration file. We create configuration file under /usr lib flume-ng conf. So in this location, this is Flume installation location. Flume installation location. It is not mandatory to save your all configuration files in this location. You can save anywhere. You can save anywhere. Recommended to place your configuration file in this location. It is not mandate. You can create your configuration file any location. While running command, we have to pass that file information. Okay. So let's first go to this directory. Go to this directory and create configuration file. So configuration file name can be any name. It is not mandatory to Flume or particular name, because while running command we give configuration file name. Let me take file read.conf. So I am creating cat or nano file read.conf and we provide configuration information. So let's discuss each configuration details. So first one, we are configuring agent. First step, we are configuring agent. We are configuring agent. This is the agent. Agent name I am saying agent 1. Agent name we are saying agent 1. You can take any name. It is not mandatory to take agent 1 or agent. You can take any name like Srinivas. So agent has how many components? Source, sync, channel, right? And I'm giving names to source, sync, channel. So agent 1 dot source name I am saying S1. Agent 1 dot channel I am saying C1, channel name. Agent 1 dot syncs SN1. So I am giving names to source, channel, syncs. Remember one more important point. If you observe here, sources, channels, sinks. You can take n number of sources, n number of channels, n number of sinks. Here the option showing sources, channels, sinks. Okay. So sources, I am taking source name is S1. So this name I am taken S1, S1, and this name I am taken C1, and this name I am taken SN1, SN1. So I did agent configuration, agent configuration. Next one. So we are getting data from file, right? I said we are going to read data from file stream. So I am providing how we are getting data to source. So there is one command here, tail command. So tail command. Before that, we are saying exec. We are getting data from command. If you are getting data from command, we give exec. So this one, we are saying we are getting data from command. We are getting data from command, exec. So what is the command we are using? Tail command. We are using tail command to read data from this file. So we are giving that information. In channel, I am saying we are getting data to source. We are getting data to source using command. What is the command? Tail hyphen f. This tail hyphen f, first whenever we type tail hyphen f, file name, file name, it reads, initially it will read complete data presented in this file, and it wait for next to enter data, next data. So whatever the data presented in this file, it will read that data and writes into channel, and next it will wait for another data. So if you enter any data next time, it will read it and writes into channel. Yep. So tail command purpose is, it will continuously reads data from file. Tail command, tail f. Tail f is a command. Tail command reads data. Tail f command, tail space hyphen f command reads data and waits for next data. It will read complete data and it will wait for next entries, next entries. Okay. So we are giving complete information to source. Source is going to get data from command. Command name is tailf and file name. And next, source configuration is completed. Next one, we are configuring channel. This channel information. If you are sending data to any source, we are saying from where you are getting. So we are saying source type is command. Command. Next, we are defining channel information. I said whatever the source is going to write, we are going to store in file channel. So for file channel, we have created two. One is data directory, another one is checkpointing directory. So source first initially writes in checkpointing directory, and from checkpointing directory to it will move to data directory. Sync reads from data directory and writes into console. So here next we are providing information of file channel. Let's see file channel. So agent dot channels dot channel name is C1 and type is file. If it is a memory, we provide memory. If it is a Kafka, we provide Kafka. If it is a database, we provide database. So channels are different, channel types are there. So initial example we are using file channel, then we are using transaction capacity 100. So transaction capacity 100. So here we have multiple options. One is transaction capacity, one is sized based. Transaction means number of events. So here source is reading data, right? Writing into here, right? So we will maintain data 100 transactions, 100 events data. Understand, right? So 100 events data. Once 100 events is completed, it will one not one event is occurred. It will remove one event data and writes into one not one event data. Or we can configure file channel based on size. You can configure this file channel or memory either transaction based or size based. So in this we are configuring transaction based. And next we are defining where is check pointing directory and where is data directory. So file channel configuration is completed. Next one, sync configuration. First we define sync information. Sync information. Sync, once data comes to sync, where it will write? It will write into console, right? So we are defining that information. So configuration of sync, agent1 dot syncs dot sn1 dot type is logger. So I am saying console logger, console logger, console logger. So whenever we type Flume command, right? Flume command, it will start one logger. So whatever data sync reads from file channel, it will write into Flume console logger. Flume console logger. Next, sync definition is completed. Source definition is completed. Channel definition is completed. Sync definition is completed. Next, relation, create relation mapping between sync to channel, sorry, source to channel, sync to channel. See, okay. Agent1 dot sources dot sn1 channels. Agent1 dot sources dot source name is s1 dot channels, means we can give multiple channels. We have channel name is c1, we have channel name is c1 and we are creating link. This source one, channel one, we created link. Yep, we are creating link between source and channel by using this option. Agent1 dot sources dot s1 dot channels equal to channel name. Next, sync to channel. Agent1 dot syncs dot sn1 dot channel equal to c1. No, sync to channel. This is sync to channel. This is source to channel. This is source to channel association. This is sync to channel association. So our Flume application development is completed. So Flume application development means configuration, just configuration, simple configuration. Okay. So we are saying how we are getting data. For channel, how we are getting data? We are getting through the command. What is the command? Tailor. From which file? This is the file name. Next, where we want to write the data? Console logger. So we, what is the file system channel? What is the channel type? Once all the definitions is completed, next, relation between source to channel and channel to sync to channel. And we, before all this, we given agent definition. Agent contain s1 source, c1 channel, sn1 sync. First agent definition, order must can be any order. It is not mandatory. First definition is agent, next to source, next to sync, channel. You can give any name, any order. Once we give command, we give agent name, right? So it will find that agent information, source information, channel information through agent name. Okay. So next, fourth step is running this Flume application. Running Flume application. So here, flume-ng. Flume-ng is a command. This command we are giving agent name. Agent name is agent-name is agent1. So in configuration file, what is the name of agent? Agent1. So flume-ng command we are giving, this is the agent name. And where is our configuration file? -conf configuration file location. So -conf slash user slash lib -flume-ng/conf hyphen hyphen conf hyphen file. File name is, what is the file name? File reads.conf, right? File read.conf. Yes or no? Our file name is file read.conf. So control X, control Y. So we've opened a file in other than user configuration, user location, right? That's why we used sudo. So ls, our file name is, configuration file name is file reads, right? File read.conf. File read.conf. So while executing command, we are saying file name is file read.conf. File read.conf, and we are providing logger information. So I said file log starts in, whenever we run command flume command, it will create a log. We are saying log is console. Log name is console. Generate a flume log in console. So this is the command to give console logger. Console logger. Let's execute this command. So before executing command, let's open one more location, one more terminal, and here uh, let me copy here. So let's see what is the input file path. For source we give an input file path, right? What is the input file path? So this is input file path, right? Yes or no? So let's open here and create a file, cat greater than file name. Okay, let's execute command. Let's execute this command. So flume started, flume read that file read dot configuration file, and if you observe here, flume successfully registered s1 source, and it is exec source is started successfully. Then in flume file, in file I am writing some message. So it is read that message and displayed in console. So then whatever the message you are writing, streaming data, this is streaming data. So you are continuously getting data, right? So where we are writing? We are writing in console. Console. Sync is writing in console. Sync is writing in console. In console. Console log. Yep. No. Generally, cameras may write in cams may write in one log file. So we create the same way. Whatever the way we created, right? Same way we create exec tail command. Then whenever camera writes log file data into log file, we are capturing using a source, we are capturing, we are writing into source. Sync reads the data. Initially, in first example we are writing in console. In next example we are going to write in Hadoop cluster. You got the point, right? So first example, sample example, I return data in console. Next example, I write sync data into a Hadoop cluster, or you can write into another file. That's destination depends upon our requirement. In first example, we return sync data into console logger. So whatever the data we read from file channel, we return into a console log. Okay. So next example, instead of file channel, next example I am going to change is memory channel. Okay. Next example 2. In example 2, instead of file channel, let's change this one to memory channel. Memory channel. So why we are moving memory channel instead of file channel? Why we are moving memory channel? First one, main advantage is fast reading, right? To increase speed or fast reading. So same open, let's open file, create a new file. Let's stop this one. Control C to stop command. Any command in Linux we use Control C. Okay. Next nano uh, file read file read 2.conf. Everything is same. Only one thing we change is memory channel. Agent configuration is same, and instead of file channel we are saying memory. We change memory and capacity of the memory and transaction capacity. It's MB. We are defining two options. One is capacity as well as transaction. So either 10 transaction, assume 10 transactions are reached first. So it will uses 10 transactions. If 500 MB is reached first, it give priority to 500 MB. And remaining is same. Logger type, source remaining is same. Okay. So control X, Y to save and quit. It will not come because we opened without sudo. So to create files in outside of user home directory, we have to use sudo permission. Next, start Flume command and pass file name. What is the file name? File read to, right? File read to. So some .text file already contains some data, right? So tail hyphen F reads all the data first and waits for continuation of data. So let's execute. So it is reading, it's starting source sync agent, and it will start reading all the data. So it is readed all the data, right? So it is readed, hi, hello, how are you, and how is Flume classes, how is your trainer. It is readed complete data, then new data, it is waiting for new data. So only one thing we did is we changed the channel type. We changed only channel type. Okay, next example. Let me save this one. Next type, instead of console log, I'm going to save data in file, HDFS sync, HDFS file system. So whatever the data coming from source, we are going to write into HDFS sync. HDFS sync. Only one change is sync definition will change. Only sync definition will change. Yep. So we give complete details of HDFS file system. So see, agent definition is same, and source definition is same. Channel definition is same. Channel we are using memory. Next, sync definition we are using these properties. Observe what is the difference of previous one. Agent one dot sync one dot type. Previously we give memory or file. Previous. Now we are giving HDFS. If you give type is HDFS, we have to provide where do we want to write file. HDFS file location. HDFS file location. I want to write in HDFS IP address of your mission 8080 in this directory. We have to specify this directory location, and file agent.sync name dot hdfs dot file type data stream. So this is data stream. Internally it uses data stream predefined techniques to write data into in this location. Okay, so we have to enter these properties, and remaining is channel. Remaining everything is same. Only one thing we changed is sync definition. Sync definition. Okay, let's save. Let's create Control C and nano sudo nano. File name is hdfs write.conf. You can take any name. hdfs write.conf. Writing Flume application development is simple, right? Very simple. In initial Hadoop development, most of the people used this technique only, Flume, to read data from streaming sources. Now people are migrated from Flume to Kafka, Flume to Spark streaming. Yep, in old projects still running in Flume only, but some projects, not all projects, some projects are developing with Flume, but most of the projects are Kafka streaming and Spark streaming. And recently, Apache started combination of Flume plus Kafka. New product they are going to release. Combination of Flume techniques with Kafka techniques. They are going to release new product. So here, let's change IP address of our mission. How to find IP address of our mission? Let's open one more duplicate session. So this is 192.168.0.46. 192.168.0.46 and 8020 is a RPC protocol, RPC port number, and this is directory. So this directory should not be exist. This directory automatically creates. Okay. Let's control X, Y. Sorry. Next, execute command. Here pass file name, configuration file name, hdfs write.conf. hdfs write.conf. Okay. Let's execute. Some.log file contains some data. It will read that data and writes into file. So this is the directory. Flume data is a directory. In this Flume data directory, every 5 seconds, 5 minutes or 5 seconds, internally it will create one file. In that file, it will write whatever the data we written in streaming source. Let's execute this command. So command is started, source is started, then it is read and return file. Let me see, we got some error. So let's stop control C. We got some error. Let's see what is the error. So it's giving Flume data slash Flume data. Apache Hadoop DFS output stream. Interrupted exception. What is the exception here? So this is the path. So this is the file name. Flume-data dot timestamp. Timestamp. If you observe timestamp, it will show how many seconds it is generating files. Given exception. So let me open browser and let's go to Flume. Sorry, name node URL. Go to the Flume data directory. So Flume data directory. So it is generated some files, right? Let me open this file. First file. Click on download. Save file. Let's open that file. Data is written successfully. And open one more file. It is writing 50 bytes. Open one more file. This one, right? Open first file. This one. No, no. It depends upon our data insertion, right? Yep. Let's remove that Flume directory. Hadoop fs hyphen rm hyphen r under root flume data, right? Flume data. I'm removing that directory. Okay, let's once again start our application, and this one file I'm stopping here and I'm reopening in overwrite mode. If we open this command, it will remove all the existed data, right? Then once again start. So it is going to create a directory first. Previously it is executed successfully, data is not available, that's why it generated interrupted exception. Let's type. We are writing where? HDFS file system. We are not writing into console. If you use multiple sinks, one sink you can divert into HDFS, another sink you can display in console. You can write multiple sinks. Let me open HDFS file system. Go to browser. So refresh, Flume data. Click on this one. See, so next let's wait a few minutes, a few seconds, and enter some data in our console. Let's wait some time. So if you press enter, it is one event. See, here it is moving some statements, right? When you press enter, every enter also one event, means space, empty space. It will write that empty space into file. Next, other streaming technologies. Kafka, Storm, and next Spark streaming, etc. See, go to HDFS file system. It may created one more file. It is created other files. So we configured capacity and size, right? So empty spaces, and go to other file. Okay, let's open browser. Let's open epoch time converter. Epoch time converter. Okay, epoch time converter. Let's open our browser. See, this is time, right? I said this is time. Let's take name this time, copy, and enter here. Press enter. So what is the time? It is written 12:52 some milliseconds. Copy this one. Just for our reference, and enter previous one, previous date, epoch time converter, and once again enter here. Press enter. So what is the time it is created? 12:52 7 some milliseconds. And take one more file generation time, then convert into epoch time, press enter. So this is 12:51. Compare time. So how many seconds it is generating? 51 to 52. So between this we have 11 seconds, right? Around 10 seconds, not 11, 10 seconds. Every 10 seconds it is created one file. For this, between this one we have 10 seconds. Between this one 17 to 50, 30. So it is following here, this one. So we configure capacity based, transaction based. Transaction based means here, so this is channel, inside a channel. So we configured transactions and capacity, but sync writing file based on the first, it will check whether file reached 500 MB or it is reached 10 transactions, 10 transactions. So we entered some statements, but after some enter statements, right? We entered some statements here, right? Here. So first we entered some statements. So these all are written in first file. First file. After that we entered some enter keyword. So transactions are happened. Then until this part it is read. We wait some time. We didn't enter anything. So file size is not reached with 100 MB, 500 MB, and file uh, memory is not reached with 10 transactions, right? After some time, we entered we entered 50, 40 seconds, I think. We wait around 30 to 40 seconds and we entered text. Then it read all these events, created one more file. Okay. So in this way, it will write files into HDFS file system. HDFS file system. Save this one. No. Okay. Hmm? Okay. That's it for Flume practical part. So we discussed three examples. Two examples are one for file channel and memory channel, and reading data from file and writing into console. Another example we discussed reading data from file and writing into HDFS file system. Okay.